Kubernetes session. I'm glad you all came here so early in the morning, especially it's not the first day, so I assume half of the people were parking hard yesterday. Well, it is what it is. Could have been earlier. Anyway, I'm glad you came here. No, it's not morning session, actually. I'm not comfortable enough to run this. We are talking about networking here, yeah, declarative networking in declarative world. Yeah, very high title, but you know, I needed to get the full somehow in 2025 because I gave this talk in kind of similar form already for like 3 or maybe 2 years. So you always need to get it updated. Yeah, so I'm Mateusz. I work at Redhat, surprise, based in Switzerland. It doesn't matter much, but you know, I like good food, good music, fast cars, but it's not my job. So yeah. At work it's mostly cloud, metal. I used to do network security, not anymore, various reasons. I never did AI till now. I'm trying not to do it for like the next 10 years. Yeah, my managers don't hear that, so I'm safe to say. So if they try changing that, you know, maybe I'll try changing it. Let's see. There is also Ben in my team, and you know, it would be shame if I didn't mention him. Well, you see he's not here, but yeah, he's sleeping somewhere in Minnesota. It's middle of the night for him, but he's really important part of this team and all this work that happened here. Also, I see a few people here that I don't mention on the slide deck, but they are here. They know that that is about them. Okay, so let's jump to the meat. Well, not yet, but basically, kind of intro question: why do we even talk about multiple network interfaces when you are talking about Kubernetes and this kind of stuff? I like to have this slide because one time after I gave this talk, someone came to me and asked me, actually, why do you even care about, Kubernetes on Metal, on bare metal, if you can just go to AWS, get the managed cluster, and that's it. And this is when I realized that we may live in this bubble that, we do heavy networking stuff, and for us, complex networking is business as usual, but there are also people out there that have no idea. For them, VM with one single network interface, this is what universe has given us, and that's it, and nothing more complex ever existed. But we have people running network equipment, not on a specialized hardware, but on commodity hardware, like software-defined routers, switches, all this kind of stuff. Telco guys, when you build 5G network today from scratch, you don't really go for specialized hardware, you go for x86, maybe ARM, if you are crazy enough, and you just run containers, and this is how we build core telco network nowadays. Then you have complex data centers with fast storage network because you need to pipe hundreds petabytes of data per any unit of time, and you cannot do it with the same network interface that you are watching YouTube or Netflix aside when when your code compiles or something like this. So this is the reality. So there are really use cases when you need to have this server with 10 super fast network interfaces, and it existed since forever. Back in the mainframe times, people were also doing this kind of stuff, and how they were configuring this stuff back in in Middle Ages when the Shakespeare was running around. Well, they had network manager, but that was basically this. They had a bunch of configuration files. So far, so good. It's Linux. Everything is a file at the end, right? Yeah, but it's not super convenient to manage that, to configure that. What you have here is basically when you get your Linux system freshly installed, Fedora on your laptop or anything, you go and you try to see how is the network configured actually. So there is a file, and in this file you configure your IP address, your interface name, and all those basic things that you need for networking. Well, this is a simple one because it has only interface name, and it says IP address will come from the DHCP. So nothing fancy at all, but the idea is that if you want to do this configuration now, so alter it in any way, you go to this file, you modify this file. So far so good, sounds easy, you vim whatever you like, you change something in the file, you quit, you save the file, or the other way around, but you get the vibe. You modify the file and you hope everything will be all right. And now, what happens if it's not? So what happens if I change something in this file? I happily save the file, quit. Now what happens is that you need to restart Network Manager. And what does it mean? So it means that actually it will stop, it will start again, it will go to this file, try reading this file, and now you get the vibe. If something is wrong in this file, it already stopped the previous run, it's in the middle of starting up, but the configuration you gave it is wrong. So what happens now? Computers are as dumb as people using them. So if it cannot start with the config you give it, it doesn't start, right? So far so good, but the server is not here, it's not the laptop here, it's somewhere in the data center in US. So if I fuck something up like this, I cannot just go and go to the terminal, modify the configuration back and restart again. I basically lost the connectivity. It happened once in my previous company that I did something like this. The server was actually somewhere in the data center at university in Korea, South Korea. Well, that was fun because I waited like 2 weeks to get it back again, but it's a mistake you make once in your lifetime and that's it. But no, it's not as bad. It's not that Network Manager is the bad guy here, because you can actually do something like this in a safer way. It's still not super smart, like, we live in a Kubernetes world, but you don't need to modify a file and then hope for the best. You can do it more interactively from the CLI. So you can open your terminal, you can type some magic command, and so what we are doing here basically in this snippet, I'm setting the IP address and try spotting the mistake. So basically, the IP address comes in the form of, IP address / subnet mask. So in this case, I'm selecting some IP address, which is perfectly valid IP address. Don't try to find any kind of hoax here. And subnet mask 24. So far, so good, right? But what I did, and this is something that was happening to me a lot in the early time before I actually understood, what is the difference between slash and backslash. This is wrong here. But, if you don't know what's what, you have no idea that this is wrong. And, if that happened in the file I showed you before, you are screwed. And basically, good luck, you go and ask for forgiveness. If you do it using the CLI interactive in the shell, it will not allow you to do this, because it will tell you invalid IP address. Okay, the error is not super clear because it doesn't tell you mistaken a character. It will just remove that one, and it will think that your IP address is actually 9924, which is incorrect for various reasons. But the main point is there is something that prevented you from breaking your system in a very miserable way. And this is already better than what we have only with the file. But let's try getting it one step further, because this is still someone SSHing to the server, and I have 1 million of those servers out there. I don't want to go one by one. I mean, you may tell me, you have Ansible, we can do it for you, but still, I don't want. It doesn't feel right, given that I live in the Kubernetes world, and we have nice, CRDs and YAMLs for everything. So I want to have something that fits the ecosystem, and surprise, surprise, we have something like this. So now imagine, instead of this ugly file that, it looked nice 200 years ago, but it doesn't look nice anymore today for people from Kubernetes world. How about this? It's much more readable. It has, some indentation. It has syntax highlighting because it's well-defined YAML. And actually, you can read it like you are reading, almost something in simple English. So you see your configuration for DNS, you have something there. For routing, you have something there. You have your interfaces. If you have a lot of them, you may have this list longer. But you get the vibe. This is something that you can quickly glance, and you see what's what. You have all the configuration for your network in one place. So here, disclaimer, this is not yet anything Kubernetes-y. This is something that exists in RHEL. You don't need to do containers, orchestration, nothing like this. You have this tool in your RHEL system and non-RHEL if you are using Network Manager, and you can benefit from that. So you can, get your non-orchestrated platform already to this level. And you know, it's super nice because it's declarative. So this is the main difference, and it's not easily visible. But basically, you define your state here, and the magic tool behind will make sure that your system is conforming to this state. So you are not modifying one parameter by one, and you don't need to take care about the order, like, you know, you don't create routes before you have IP address and all this kind of stuff. You need to know that if you want to execute a set of commands. Here, no, you just create one huge YAML file, you give it to the tool, and the tool knows what is the order of things that you need to do. If you want to create a VLAN and then, you know, assign IP address and you want to plug this interface to some bridge, you don't need to think about order of things like you need with Ansible. You don't care if, oh, do I need to first create the bridge and then interface, or the other way around? No, just forget. Just write what you want your system to look like, and that's it, and you get that. So actually this tool, yeah, this is what it does. Now we are doing hard switch to Kubernetes. It's not involved in pod networking. So you may now start thinking, oh, but then we have pod, one network interface, pod gets IP address, something like that. That's not this, you know, it's not the room here. We are using this in Kubernetes, but this is purely for host networking. So this tool is not involved with how your pods get connectivity, how you access your services that you run in Kubernetes. That's not the thing. We are still in the world of, you know, nodes that form your Kubernetes cluster. That's it. And the tool has multiple features. So basically, whatever you can configure with Network Manager, you get in this tool. So bonds, VLANs, VRFs, bridges, all this kind of yada yada. You get this all. If you are missing something, tell us, and you won't be missing this anymore. And now, how to make this happy marriage between these two, Network Manager and Kubernetes? Because Kubernetes operates on CRDs, which is, you know, YAML, but it's not only YAML. It needs to have a structure. It needs to be well-defined API. So what we do, so we define a CRD, which we call Node Network Configuration Policy. Don't ask about the policy part there. Think about this, like, you know, node network configuration. That's all you need. And, you know, it has some syntax sugar over Kubernetes, like, you know, node select or some metadata. But the meat is that you define desired state. We even named it desired state, so you don't think about order of things and stuff like this. You tell us what you want. This is what I desire, and you basically define on interfaces. So this is super simple because I'm just taking two interfaces, if one, if two. I'm setting MTU for them. That's because I could also skip that. And I'm creating a bond out of those two interfaces. As simple as that. I could do it with, you know, 3 to 50 commands using shell, or I can do it with one YAML. And I didn't say that yet, but the fact that it's now Kubernetes API and we have an operator behind, which I will demo in a moment, gives you also what Kubernetes gives you, that there is something, and this something is called Kubernetes basically, that makes sure that this configuration still stands. And this is important part, because so far, you know, you think, okay, I'm the admin of my server, I configure networking, and it's like this forever. That's not the case, because what happens now if your colleague SSH to the same server and starts tinkering with configuration and accidentally, or not accidentally, removes yours? You don't even know, because you don't track what all the people out there are doing. So let's use Kubernetes to get also this. So I will give you a short demo. I hope that works because I'm doing this live so you know how that works. The gods of live demos, I hope they are with me. Yeah, so I have a bunch of manifests. So the first one, what I will try to configure DNS server. As simple as that. But what is the trick here is I will configure my system to use DNS server, which is wrong. in the sense that, this is a perfectly valid IP address, even if it doesn't look right. Don't ask what it is, it's link local IPv6 address, but it's correct. I'm not trying to, to trick you into anything. This is a perfectly valid IP address, but I don't run DNS server there. So what is the point of configuring my system to use DNS server, which is not a DNS server? Well, it's bad configuration. So I want something to not allow me to configure that, right? So what I will do, I will apply this configuration, and just before I do it, I will show you the current configuration of my system. So I just changed the terminal, and this is the configuration of this system I have. So I have 3 name servers. I have some of them that are commented. Well, you don't see that they are commented because something is here in the terminal, but basically I'm not using those. You just care about the ones at the top, and I will apply this manifest. Okay. Okay, for some reason, okay, it failed fast. it failed faster than I wanted. Well, configuration is not here, but you don't need to believe me because maybe nothing happened. So let's see what actually happened here. Okay, it failed for some reason. Maybe we'll get some nice log actually. So yeah, this is how it works with Linux. We are in the worker too. So let's try. See logs. Yeah, that's a longer message. You will have it on the recording, but you need to trust me. So why it failed? Because I actually, so this is, I basically over-engineered. So what I was doing, I was applying the DNS server on this interface ENP2 as 0, but on my system the ENP2 as 0 doesn't have any IP address. It's not interface that is up. So actually it makes completely zero sense to apply this configuration. Well, so yeah, it didn't work for a different reason. So maybe I have a manifest that configures something correctly. Yeah, I have one for the correct. Yeah, so this is, so what we, yeah, same thing happened. Okay, we're back. Yeah, but I'm actually not sure if this is the, because we had it during the test setup before, so yeah. But it comes back quickly, so yeah. So okay, so I will modify this manifest here to configure to something that is valid. There is no point in spending too much time on this particular one. Okay, so we have configuration progressing, and if I open the file now, you see, so it actually changed the configuration. Well, this one will not fail and get reverted because this is actually a DNS server that is out there and I have connectivity. So this is something you are speedrunning to what I'm trying to, yeah. So basically you ask what happened if I had configuration that would, for example, break the default route or so. Yeah, so I had something else about this, but basically to answer the question, if you have configuration that breaks the default route and it really breaks it, we will not apply this configuration because we check. So basically what we do is that we create a checkpoint, we try your configuration, if it broke connectivity and you were you either know or you guessed right. We check if you still have connectivity to default gateway. If you lost connectivity to default gateway, meaning you cannot ping it anymore, we'll revert your config. So you will not get a chance to break your system. So now what I want to do, because I also told you that it will protect you from some other guy going to your system and changing the configuration. So I have this short manifest that basically takes the interface, it adds IP address to this interface, and that's it, nothing more. So let's go to this system which is master 0. And if I show you the configuration of this, we are looking at 3.0.4.0 here. They don't have this IP address, right? So far so good. So I'll just apply this configuration. And we...
Hopefully it comes back. I call for help.
So let's wait for a moment. Okay, so we have the additional IP successfully configured. Let's go to the machine. And you can see we got this IP address, right? So now what I will do, I'm this kind of, stupid admin that now goes and removes this configuration. So I will do IP delete from the device. This is the device. Sorry, didn't copy everything. Okay, so far so good. I lost this one. Now, it doesn't happen immediately, and this is for performance reasons, so I think the timer is something between 120 seconds and 5 minutes. So I will kickstart this very quickly so that it reconciles faster. Get pod. I'm on master 0, so this is the one. Delete the pod. And now I have it starting again. Okay, so it started. I have the NMstate available, and if I go to my machine again, I got the IP address again. So basically, API server in maximum 5 minutes would notice that something is wrong with the configuration. The configuration doesn't match the desired one in my CR and reconciles that. So I think given that we don't have so much time, I could also show you the configuration that applies the static route, but it would be basically the same. Then I would delete the static route, it would create it again, and that's it. But that's the demo. You can watch it in one of my other talks, because here I want to give you still some overview of the tool itself. So the tool itself, which stands behind all this stuff that you saw in the demo, it's written in Rust, because why not? I mean, it's nice and Chris likes it, so let's do it. It's nicer than some other languages that we have in the ecosystem. Network Manager as a backend. This may sound obvious, but there is a lot of platforms that don't use Network Manager, so we are working with them. I don't want to say too much, but basically there are people who made NMstate work with Ubuntu using NetPlan. It's kind of hackish and it's not yet upstreamed. I'm not sure if it will ever be. It's more political than technical problem, but today, as it stands, you need to use Network Manager. We have Kubernetes operator because we just saw this operator. And if you want to use the tool, the NMstate itself, not via Kubernetes, but from some other tool of your choice, we have bindings in Rust, Golang. I'm not sure if we still maintain Python. We may have removed that. We still do. Okay, nice. So you have Rust, Golang, Python, maybe something else, maybe not, but the most important, you get them. OpenShift integrations, there is a lot of them. So basically the operator that you saw, the API installer for the OpenShift itself, it also uses this tool heavily. Assisted installer, yet another installer. It also uses this tool heavily. Agent-based installer, yet another installer. We have like 500 of them, but they all use this tool somewhere in, somewhere in the background. NMstate on the host, well, obviously you can always SSH to the cluster and do stuff, and then you have this tool. Also machine config operator, which is, implementation detail. I will not be talking about this, but it also uses that. So basically, wherever you look around in the OpenShift ecosystem, everything is using that. So this is really a monster in the sense that it's like, like this Hydra that has its hands everywhere. And in general, this is something that I could have started with, but I have it later. Why to use NMstate? Well, basically because networking is complicated. People don't understand networking. People don't want to understand networking, and they need something that will take all the heavy stuff from them. And we think NMstate is the tool that makes networking accessible to everyone. You don't need to know anything sophisticated. You just need to know what you want, which is always the biggest problem, of course, but at least you have one problem now, not 10 problems. And it's not like silver bullet. There are reasons why not to use NMstate, and this is purely in the OpenShift ecosystem. Because of course, once you have one tool to configure networking, you have hundreds of them. And they never live nicely together with each other. So we have, machine config operator configures networking in some way. Then we have, I think, a dozen of single-purpose operator, like, someone created bridge operator, and the only purpose of this operator is to create Linux bridge. Then someone created some other operator, I don't want to throw names, that configures only one thing that they needed. But none of those single-purpose operators thinks about the ecosystem as a whole. We do. That's why we are basically pushing for NMstate operator as the way to do it, and not, dozens of different operators. What I scratched here is that till now, till I think 4.16 or 18, it couldn't be used for day 2 operations. So basically, once you install your cluster, the configuration stays. This is not true anymore. I can talk details for the next 5 hours, but basically you can use that now to change configuration of the cluster that you already installed. And this is something super cool. People really wanted this, but we don't have time to go deeper. Well, you cannot have everything. So yeah, this is what I put here. So the configuration is already GA, and yeah, one more point. Yeah, this is silly, but I have it here. Is that if you configure a networking using one tool, it reduces configs, and it's easier for you as a system manager, as a system admin, to think about your flow. Because it's easy not to see this argument if all you manage is your home lab with 1, maybe 2 servers. But once you start managing 10 clusters, 200 servers each, you need something that gives you consolidated view. Otherwise, you are going to fail as an SRE or whatever your title is. NMstate versus MCO, I will skip that. This is implementation detail. We could talk about this, but we don't have much time. Versus single-purpose operators, this is something I told you. If you have an operator that can manage everything and it's a good operator, why using 10 smaller ones? It's political, but it's a point that I want to make here. What we did in the tool since the last time I gave this talk, we added in-cluster usage metrics, so you can basically get metrics about the features people use. So you can see, okay, 100 interfaces uses static route and this kind of stuff. It's nice, people want it. You can, plug it to your Grafana and see how people configure networks. Performance improvements, this is of course something I cannot show easy on the graph, but people started benchmarking us on hundreds of manifests, hundreds of nodes, hundreds of interface. So basically go hundreds in 3 dimensions, and it exposes a lot of problems. We solved a lot of them, we still have a lot of them, maybe even more, but We added also some custom configuration because we are small and very opinionated. Once everyone started to use us, people need more configurability, so we are adding this. What we are planning to do in the next half a year, maybe next 5 years, we'll not be reverting rollback in configuration when you delete the NMCP. I didn't talk about this at all, but if you know what that means, then you will be very happy. Some syntax improvements, because once you get more customers, they tell us, oh, this is actually not super intuitive, so we are iterating on the API. It can still change, and we are adding some nice stuff there. More performance stuff. Because the more we benchmark, the more problems we discover, the more problems we fix, the more problems we introduce. So it's a never-ending story. For a moment, we're thinking about publishing as Helm chart, because right now we go only through OLM, which is a problem for people doing vanilla Kubernetes. They don't like it very much. So we need to work with those people and find out the nicest way to do it. And something purely political, maybe joining some Kubernetes SIG or CNCF or some working group. This is basically because we want to get more contributors and more people to the ecosystem. Right now, it's basically Red Hat project maintained by Red Hat. It's officially upstream project, but in reality, it's Red Hat Playground, and you don't really get external contributors if you don't go to some organization which name is different than Red Hat. And that's it. So I think we have moment for questions.
Thanks. I wanted to ask whether you could please elaborate a bit on how the different NNCPs are merged together into a single NMstate configuration. For example, you showed how to add an IPv4 address on an interface that had none. But what if I already have one interface defined in one NNCP, I want to define a second, for example, in a different NNCP? I mean, will the interface have the two interfaces? One will take precedence over the other one?
Basically, the problem you are asking here is kind of philosophical, whether you should have one big NNCP that configures everything, or whether you should have a million of small NNCPs that will then merge together to one unified configuration. And this is something we try to educate users on, is that they should have one NNCP in which they define everything and let us figure out what is needed to apply your configuration. Because we don't want people to repeat those mistakes that they are used to, running command by command like they do in Ansible, that they define stuff step by step. We want you to craft one huge YAML in which you say how your whole system should look like. So if you have two interfaces, don't create two NNCPs. Create everything in one NNCP and let us figure out the order of stuff and what. This is basically the mistake I did here. I had one NNCP to configure IP address and the other NNCP to configure DNS server, and I should have never done it. I should have created one NNCP that configures all I wanted to have, because I was trying to outsmart the tool, and the tool outsmarted me.
Okay, and also another question. Have you considered doing something like create, for example, some parameterization to the NNCPs or something? I'll make the example I have in mind. Imagine you have a fleet of servers. You want the very same networking configuration in each of them, but the only single difference in the configuration would be a static IP that must be static. You are not allowed to DHCP. And you want to have that same. Nowadays, you will have an NNCP per server with the only difference being the IP. So will there be a better way, or will you consider it?
Thinking about this because it comes on a recurrent basis, and to be honest, I don't have a good solution to this, because whatever we would need templating or basically templating to what we want, wouldn't be aligned with how any other CRD in Kubernetes works. So right now the solution is to create NNCP per server, and if we find out a nice way to have this template fit Kubernetes ecosystem, we are happy to implement that, but it needs to be smart, because it cannot be mixed of Puppet, Ansible, Kubernetes all in one. Yeah, so I'm not sure we have a nice way to do it today. We can discuss if you think there is one.
Okay, I was thinking something similar. Or maybe just like some environment section.
Yeah, so there is a lot of ideas, but none of them fits nicely in the ecosystem, so we really need to discuss carefully that. And that's it. Thank you very much.
That's all. Thank you very much.